So, right when the disaster in BP was beginning, a few friends of mine asked me what I would do to fix that problem. My name is Hiram. I am a mechanical engineer, and I told them that it would be no different than what is being shown here in this kinked hose. I would fix it just like I would fix leaking pipe in my house. So, bear with me here as I explain my method and my proposed device. Again, the physics are no different than what this hemostat does when it's kinking a blood vessel. So right now I'm going to demonstrate what happens. I got this steel brake line. Simple, silly experiment is being mated to a hose by a bar fitting and some clamps. We got this hose that goes to our fluid source, in this case, a regular water faucet. Again, this is just to show the physics behind it, which is what matters. So I'm turning the flow all the way up, have a good flow of water on the other end. This stick here is nothing more than a paperweight to prevent the momentum from the water knocking that pipe off of the table. So you got a nice feet of fluid shooting out of the spout. Right here I'm showing a combination German pliers, and what's important here is the cutting edge there, which we'll use to put a kink in that line. So, I struggle with this one because it's not the right size. I would have used my larger pliers, but I couldn't find them. And once they got slippery here, it was hard to get a grip, it was hard to press on them. But a larger pair of pliers, as I found out, created a perfect seal later on. So, just to prove a concept here, you apply the force, you can see the flow decrease, no different than what you see at a car wash with those nozzles they use. You got a lot of fluid velocity, but very little fluid flow, which is what we want down there. So, you can see it sprint, you can see the flow has decreased substantially. Here I'm going to show you what the results of that was. You see 2 or 3 kinks on that line, which create the seal. And the problem I had was even that there was such a pressure spike from the seal preventing that flow that it just popped out. It slid off of the plastic hose there because it's a good seal. So this is the device that I propose. It's gone through a few revisions, so it doesn't look like this anymore, but the concept is that you have 2 wedges surrounding the pipe, here pointing in red, lightly drawn. We got a stationary crossbar wedge that creates a support for the structure and also as a mating surface for the other wedge. You got a parabolic deflection crossbar, similar to the opposite end, but this one is parabolic. And what I mean by that is that you got this U-groove section that mates onto the other wedge, and that's important, and you'll see why. So we got this combination frame rails that hold the structure together, prevent it from tearing apart, and we got these bolts or studs on either end of the device. Again, to keep it from tearing apart. And here's the heart of the device, the actuated wedge. It moves in one direction, slides side to side, and it has these integral rail guides, which have changed already in the design stages. This is just as a proof of concept. What these do is they ride on the grooves of the frame to prevent it from moving in any other direction. So here's what's going on. We got explosives that actuate the wedge, the actuated wedge. Explosives are better in this situation than, say, hydraulics, pneumatics, or electric activation. They're fast and they create the force necessary to move that wedge and to create that necking that we need. And you got these mile-long leads that are easy to source, much easier than pressure pipes that would run for miles. And that's all you need. I mean, you need a signal to detonate those explosives. And here's a cross-section of the device. You got both wedges on either side. You got the parabolic deflection crossbar. You got the bolt stud there that holds everything in place, the rail guides, and you got the necking action that this device creates. What's great about the necking action is that you got a weldable cavity at the top that you can use either submarine welding, or if I were to do it, I'd choose a waterproof container full of thermite that you could remotely ignite, and that would give you both the filler and the exothermic reaction needed to weld that shut. Again, the device is very simple. I mean, I don't see a group of dedicated and competent tool builders taking more than a week to build a device. And what's great about it is that you can install it in existing rigs to prevent any disasters like this from happening again. I mean, you can have one at the top where the rig is, one in the middle, and one at the bottom of the sea, so that wherever that rupture occurs, you can have a source, you can have a fail-safe to prevent any leaks. Again, my name is Hiram, and this is the device that I propose, which would quickly and efficiently take care of this problem. Thank you for watching.